questions 21 through 25 on the 2007 grade 11 Fermat math contest. 5 consecutive positive integers have the property that the sum of the second, third, and fourth is a perfect square, while the sum of all 5 is a perfect cube. If m is the third of these 5 integers, then the minimum possible value of m satisfies. X plus 1, x plus 2, x plus 3, and x plus 4 represent our 5 consecutive positive integers. And they tell me that the sum of the second, third, and fourth is a perfect square. So the second, third, and fourth, when you add them up, they are a perfect square. So I'll call that n squared. So this looks like 3x plus 6 is n squared. And I can factor out the 3 and I get x plus 2 is equal to n squared. All right, now let's look at the next sentence. The sum of all 5 is a perfect cube. So x plus 1, all of those is a perfect cube. So I'll call that p to the power of 3. And when you add all this up, it becomes 5x plus 10 is equal to p cubed. Factor out of 5 and we get x plus 2 is equal to p to the power of 3. So that's just the initial setup of the question. Now they're telling me that m is the third of the 5 integers. So the third of the 5 integers is this right here, and they're saying that is equal to m. Okay? Well, interestingly, that is right here and right there. So instead of x plus 2, I can put in the letter m. So that becomes 3m is equal to n squared, and this becomes 5m is equal to p cubed. All right, so where do we go from here? This is about the end of the road for us, right? With regard to the question stem. From this point on, we have to figure out what to do. So what do I do here? Do I take the square root? Do I take the cube root? Do I subtract? Do I add? Factor? Well, the best way to approach this is to just look at it from the perspective of the fact that 3 times m must be a perfect square. So, for example, if m was 3, then it would be 3 times 3, and that is indeed a perfect square. So that works. But does it work over here? Well, let's see. If m is 3, this becomes 5 times 3, which is equal to p to the power of 3, and that's 15, and 15 is not a perfect cube. So you see what I mean? We have to experiment with values of m. But we don't have to experiment too long because there is a system you can use. The first thing, of course, is to recognize that 3 times something is going to be a perfect square. So I'll put that m on top like that. Now, in order to get a perfect square, m has to have at least a 3 in it in terms of the factors of m. That's the only way. And then the rest of m, we don't know yet. But there's got to be at least a 3 in there because this 3 has to have a matching 3 for it to be a perfect square. Okay, so far so good. The exact same kind of thinking over on this side. P to the power of 3. And I'll put the m on top. Now, I've already got a 3. M has to have a 3 in there. So far so good. But this 5 tells me that there also has to be 2 5s. Like that. That's the only way we're going to get a perfect cube. 5 has to have 2 more 5s to become 5 to the power of 3. All right? Now, with the same thinking, the same logic, there has to be 2 more 3s. That's the only way 3 can become a perfect cube. If there's 3 of them, it would become 3 to the power of 3. So there you go. That is what m is. I'll put that over here. 3 times 5 times 5 times 3 times 3. Now, of course, m could be other things as well, but they want you to figure out the minimum possible value of m. So this is the minimum possible value. And if we multiply this out, we get 3 times 5 times 5 times 3 times 3, which is equal to 675. So that is the minimum possible value of m, and therefore that is going to be between 600 and 800. So the answer to number 21 is D. A ball placed at point P on a rectangular billiard table is shot at a 45-degree angle to the edge of the table. After successfully bouncing off the edges of the table at 45-degree angles, it returns to point P, as shown. If the ball travels 7 meters, the perimeter in meters of the table is closest to. So we are told that this angle is 45 degrees. Okay, so that is basically all that we have been told. But that's not true, because they say that successfully bouncing off the edges of the table at 45-degree angle. So every time it bounces, it makes 45-degree angle. So that means that this is 45, that's 45, and that's 45. Now, the fact that this is 45 is very helpful, because that means that this side is the same as that side, because that's an isosceles triangle. So what I'm going to do is label that x. And based on the symmetry, this is also x. Those are essentially just rectangles. Now this distance from here to here I don't know, so I'll call that y, and therefore that's y, this is y, and that's y. Okay, these are basically two identical rectangles. So my distance, they tell me, is 7 meters, and in terms of my x and y, that is 4x plus 4y. Correct? And I can factor out a 4x plus y, and basically x plus y therefore is equal to 7 over 4. So that's the first part of the question. The next part of the question involves a lot of Pythagorean relationships. So I usually don't like introducing a lot of variables, but the good news is that all of these variables will be in terms of either x or y. So here we go. The first one right here, I'll call that a. And therefore, x squared plus x squared is equal to a squared, right? We're using this triangle and the fact that this is 90 degrees right here. All right? So that leads to the following. A is equal to root 2x. Okay? No tricks, just standard algebra. In a very similar way, I will discuss that and call it b. That is y squared plus y squared is equal to b squared. And that leads me to b is equal to root 2y. All right? And we're going to do that for this, and then this, and then this, and then this. So the same thing. This part here is symmetric, so that's c and that's c. So that basically means that 2c squared is equal to x squared using Pythagoras. That leads to c is equal to x over root 2, and therefore 2c is equal to root 2x. And in a very similar way, call those d's, and at this point you get the hang of this. 2d squared is equal to y squared, and that leads me to d is equal to y over root 2, and therefore 2d is equal to root 2y. And same thing, call these e's or f, it doesn't really matter, whatever letter you want to use. And therefore e squared plus e squared, you get the hang of it by this point, you're an expert, is equal to x squared. And that leads me to e is equal to root x over root 2, and therefore 2e is equal to root 2x. And finally, 2f squared is y squared, and that leads to f is equal to y over root 2, and therefore 2f is root 2y. So there we go. We're done. So the full perimeter of this billiard table is, let's see here, a plus b plus 2c plus 2d plus 2e plus 2f. Now, good news is that we've got all of these in terms of x and y. A is root 2x, b is root 2y, 2c is root 2x, 2d is root 2y, and 2e is root 2x, and 2f is root 2y. So this looks like, collecting like terms, we got 3 root 2x and 3 root 2y. Factor out the 3 root 2, and we get x plus y. Now, x plus y, we figured out earlier, was 7 over 4. So 3 root 2 times 7 over 4. And I believe they want you to figure out a decimal value for this. And if you do that, you get approximately 7.42 for the perimeter. So let's see here. 7.42 is closest to 7.5 of the answer choices. So 22, the answer is B. An ugly light fixture is hanging from point O on the ceiling. Wires OXM, OYN, and OZP pass through the vertices of a very thin wooden equilateral triangle XYZ of side 60 centimeters. A small bulb is attached to the end of each wire. The plane of the wooden triangle is parallel to the ceiling. If each wire is 100 centimeters long and the lower end of each wire is 90 centimeters from the ceiling, what is the vertical distance between the wooden triangle and the ceiling? We will do this question in a series of steps. The first step is I'd like to talk about the ceiling and the relationship between O, X, and M. So we'll just draw it in like this. Okay? Something like that, right? So here's the ceiling right here. I'll write C for ceiling, and then here is O, this point. This is X, and this is M. Okay? Now, they give us quite a bit of information. They tell me first and foremost that the wire is 100 centimeters long. So that means this distance is 100. Okay? And then they tell me that the distance from the ceiling to the bottom of M is 90. So if I were to extend this line from X to the ceiling, this entire distance from here all the way down to M, they're telling me is 90. All right? So what we are asked in this question to find out is this right here, this red line, which I will call X. That is the vertical distance from the wooden triangle to the ceiling. Now, if this O to X to M is 100, then I can figure out some sort of a relationship. The first thing I will do is figure out X to M from here to here. Well, that's basically 90 minus H. So therefore, this distance will be 100 minus 90 minus H. And that is 10 plus H. So there we go, 10 plus H. So that's the first part of the setup. And the next part is I'm just going to use the same diagram that they give me in the question, is drop a line from O down to the bottom right here so that it touches that equilateral triangle. Okay? And then draw a line from X to touch the bottom of that. That is a triangle that is a right triangle. This is basically a right angle. And that is the triangle that's going to help us solve for H. So let's label this triangle, OX, we just figured out over here, is 10 plus h. This distance from O down to the base of that triangle is h. That is what we are trying to figure out. Now this distance, that is what we have to figure out. That distance I don't know. So because it's along the base, I'll just call it B for base. If I can figure out B in terms of a numerical value, then I can figure out h using Pythagorean theorem. So how do I figure out B? Well, the first thing is look at the question. They tell you that XYZ is an equilateral triangle. So I'll draw an equilateral triangle. And now I'm going to draw lines from the vertex to the other sides. And that will allow me to figure out a very important point in this equilateral triangle. And that important point is right here. That is officially known as a centroid, not a center, but whatever you want to call it. That is important. Why? Because that represents this point right here. That point. That is where that line H hits that triangle. And therefore B on this diagram of this equilateral triangle is this distance right here, from there to there. So if I were to label this, this is X, this is Y, this is Z, and this is B right here. The distance from X to the centroid. All right, well, that's great, but how do I figure out that distance? And that's where this comes in. 60 centimeters is the length of each side. So this is 60, this is 60, like that. Now, the line that I drew from Z to the other side, it cuts that in half. So therefore, this becomes 30, and that becomes 30. Now, it's an equilateral triangle, so that angle was 60, right? All of those angles were 60 degrees. But when I draw a line, it cuts that angle in half. So this becomes 30 degrees. And this is 90 because that was a perpendicular, and therefore this is 60 degrees. So yet once again, we have a 30, 60, 90 triangle. And the ratio of the sides of a 30, 60, 90 triangle are 1, 2, and root 3. Okay? So from that, we can get the value for B, the actual numerical value for B. B over 30, this side over this side, in terms of the ratio, is 2 over root 3. Okay? So that means B is equal to 60 over root 3. And there you have it. We have everything we need to solve for H using this triangle. And let's do that. I don't think we will need much space. I'll just do it on the side here. This triangle, in terms of a Pythagorean relationship, is going to give me this formula. B squared plus H squared is equal to 10 plus H all squared. B squared is 60 over root 3 all squared. H squared, I don't know. That's what I'm trying to figure out. Expanding this, we get 100 plus 20h plus h squared. The h squareds cancel, so all we are left with is just 60 squared over root 3 squared is 3,600 over 3 is equal to 100 plus 20h. So 3,600 divided by 3 is 1,200. 1,200 minus 100 is 1,100 is 20h, and therefore h is equal to 1,100 over 20. And h is therefore equal to 55. And therefore 55 is the answer to number 23, which is choice D. A line with slope 1 passes through the point P on the negative x-axis and intersects the parabola y is equal to x squared at points Q and R as shown. If PQ is equal to QR, then the y-intercept of PR is closest to. Any line is of the form y is equal to mx plus b. Now they have told us that the slope is 1, so that means m is equal to 1. So therefore this line is y is equal to x plus b. This line right here. Okay, so that's pretty straightforward. And let's find the x and y intercepts. I don't know if it's needed, but let's do that. When y is 0, this becomes 0 is equal to x plus b, and therefore x is equal to minus b. And that is where this line crosses the x-axis. So that's right here. That p is basically 0 for the x coordinate, for the y coordinate, and then minus b for the x coordinate, like that. And then we have the same thing for the other coordinate, which is right here, where it crosses the y-axis. So to get that, you set x equal to 0, and if you do, you get just y is equal to b. So this coordinate right here is 0b. So I'll just put that in there, 0b. So the other thing that they tell me is very important. PQ is equal to QR. And this will probably be the formula that helps us solve for this letter B. And that is essentially what they want us to find. They want us to find the y-intercept of PR. So the y-intercept of PR is right here, 0b. So B is really what we have to figure out in this question. So the first thing I need to do is figure out the coordinates for Q and R. Q and R are the intersection points between the line y is equal to x plus b, which is this line, and the parabola y is equal to x squared. So set them equal to each other and solve, and we will get the following. Bring everything on one side, x squared minus x minus b is equal to 0, and now we have to use a quadratic to figure out the value of x. So this gives me minus b plus or minus the square root of minus 1 squared minus 4a minus b all over 2a, which is 2 times 1. And if you simplify this, you get 1 plus or minus 1 plus 4b all over 2. So these are the x coordinates for Q and R. This being Q and that being R. So now we have to figure out the y coordinates, and the good news is that to figure out the y coordinates you just have to plug it into that formula. So really all you're doing is adding a b. So Q, that coordinate, will be 1 minus 1 plus 4b square root divided by 2. And the y coordinate will be 1 minus 1 plus 4b all over 2 plus b, right? You're just putting the x coordinate into that formula to get the y coordinate. And then in a very similar way, r is the other one, which is 1 plus 4b square root all over 2, and the y coordinate of r is 1 plus 4b all over 2 plus b, like that. Okay, so we got our p and q coordinates. Now we have to use this. PQ is equal to QR. All right, so what is, first of all, p? P is minus b0, minus b0. Okay, so I'll put that in here, minus b0. All right, so here we go. We have to use, of course, the distance formula. P to Q will be 1 minus 1 plus 4b all under the square root all over 2 plus b. right? Because it's P to Q. So it's this minus that. That's why it became a plus, because it's subtracting negative b. All squared plus P to Q 1 minus 1 plus 4b all squared all over 2 plus b, and minus 0. We can put that in there. So basically what I did was this, subtract that coordinate. And this is all under the square root sign because it's a distance. And that is equal to QR. So the exact same way, QR, that's going to be a little bit longer. 1 plus 1 plus 4b all under the square root all over 2 minus 1 minus 1 plus 4b under the square root over 2 squared, and plus, now I have to subtract the y coordinates. So in a very similar way, all under the square root sign. So this is the formula I have to solve to get the value for b. But the good news is that it's actually not as bad as it looks. It looks terrible, I know, but it's actually not that bad. We can simplify pretty quickly here. So first of all, square both sides, get rid of the radicals, right? And let's collect as many like terms as we can. So we have the following. And then at this point, you can notice very quickly that this is the same as this, and this is the same as that. So we add them. And when you do that, you will be able to cross out the 2's on both sides, and all you are left with is a fairly straightforward equation. And in addition, you can also take the square root of both sides to get rid of these square roots, or squares rather. And at this point, let's multiply through by 2 to get rid of the fraction. And now let's collect like terms. We get 3, 1 plus 4b under the square root sign. And on this side, we just have 1 plus 2b. And now we take the square of both sides. And this gives me 9 times 1 plus 4b. The radical disappears. And this becomes 1 plus 4b plus 4b squared, like that. Simplifying and placing everything on one side, I get 4b squared minus 32b minus 8 is equal to 0. And divide through by 4, and this brings me to b squared minus 8b minus 2 is equal to 0. And unfortunately, this doesn't factor, so I can just use a quadratic. So b is equal to minus 8 plus or minus the square root of minus 8 squared minus 4 times 1 times negative 2. All under the square root sign, all over 2 times 1. And this basically is 8 plus or minus the square root of 72 over 2. And if you do this in terms of a decimal, you get 8.24 for the only value of b that makes any sense. So therefore, number 24, the answer is closest to C. How many ordered pairs BG of positive integers with 4 less than or equal to b, less than or equal to g, less than or equal to 2007 are there such that when b black balls and g gold balls are randomly arranged in a row, the probability that the balls on each end have the same color is 1/2. The first thing we need to do in this question is figure out a formula. And once we figure out the formula, then we can use these parameters and figure out how many ordered pairs we can get. Now, to understand the formula, it's best if we start with a small example. Otherwise, the formula will not make any sense. So here we go. Let's say we have the following in terms of b and g. We've got 2b and we've got 3 g's. So basically we have 2 balls that are black and 3 balls that are gold. And I want to figure out how many of them, in terms of an arrangement, have the same color on each end, exactly the way that they are describing in the question. The balls on each end have the same color when they are arranged in a row. Okay, well, that should be pretty straightforward. It's one of these. We have either black on both ends and then 3 balls in the middle, or we have gold on both ends and 3 balls in the middle like that. Okay, that's great, but I need to know how many in terms of a number. How many of these are there? And then I also need to know the entire total number, because I have to, in the end, figure out a probability, and that probability has to equal a half. All right, so first let's figure out the total. The total combinations will be as follows. First, you have 5 balls, right? So from those 5 balls, you have to choose 5 in this row. So, for example, you've got 5 slots. For the first one, you got 5 choices, correct? For the second ball, you've got 4 choices. For the third ball, you got 3, then 2, and then 1. And then, of course, you multiply them all. So this is basically 5 factorial. That is the total number. But this overcounts quite a few. Why? Because they're the same letter. So, for example, if I were to call this B1 and B2, notice B1, B2, GGG is the exact same as B2, B1, GGG. See what I mean? So because of this overcounting, we have to divide this 5 factorial by something. What is that something? Well, how many B's do we have? We've got 2 of them, right? So we have to divide by 2 factorial. How many G's do we have? We have 3. So I have to divide by 3 factorial. So that is how I figure out my total. Just in case you're wondering, this equals 10. So my total is 10. Now, I'm also going to write this in terms of B's and G's. So how did I get this in terms of B's and G's? Well, basically what I did was B plus G factorial all over B factorial times G factorial. There we go. That is the total. And I got a numerical value of 10 just to sort of illustrate how this will work. Now I've got to figure out how many of these guys and how many of these guys. Okay, so let's first start with the top one here. For that one, how do I figure out how many of those in terms of a numerical value? Well, the B here and the B here are fixed, correct? Now I initially started off with 2 B's and 3 G's. So the only possibilities for this is the 3 G's. G, G, and G, like that. So there's really only one possible way of doing that. But the number is great, but I need a formula in terms of B's and G's. I can't just put a 1. Okay, how did I do that? Well, these B's were fixed, right? These 2. So that's a done deal. Now I have to figure out how many combinations can I place in the middle. Well, very similar. How many are there? There's 3. So the combinations will be 3 times 2 times 1 for these guys. And that gives me 6. Now you say, well, there's only one way of putting them like that. How can you possibly get 6? Because, just as before, I have to divide by something. What do I divide by? How many G's do I have? I have 3. So I have to divide also by 3 factorial. And when I do that, this becomes just 1. And that's why it is 1. Okay, that's great, but I've got to get this in terms of a B's and G's. No problem. First, how many g's were there? Well, there's 3, correct? And how many b's were there? There was 2. So I had 5 in total. And from those 5, I subtracted 2 to place on either end. So from b plus g, I have to subtract 2. And I have to take that factorial. That is the top number. And in our case, it worked out to be 3. And that's how we got this 3 times 2 times 1. Now what about the bottom? Well, remember, this overcounts if I just left it like this. I have to divide. Divide by what? What am I placing in the middle? Well, I'm only placing g's. How many are there? There's 3. So I have to divide by 3 factorial. And in this case, that's g factorial. Okay? But I also have to divide by the b's. How many b's were there? There was 2. How many did I place on either end? 2. So I have to write b minus 2 factorial. That is very important. So this is my formula for these guys right here. Now in a very similar way, I have to figure out my formula for that scenario. Same thing. First, let's do it in terms of numbers. We've got a g here and a g here that's fixed. So those two I don't have to worry about. But then I've got these left over. I've got 2 b's and a g. So I've got 2 b's and a g. I can place it like that, b, b, g, or I can place it like b, g, b, or I can place it like g, b, b. So that gives me 3. So my numerical value is 3, but I've got to come up with an explanation for how did I get 3 in terms of b's and g's. Okay, no problem. First, let's do it in terms of numbers. In terms of numbers, how I got that was as follows. I basically did the following. How many, first and foremost, numbers do I have to place in the middle? 3. So it's 3 factorial on top. But then I have to divide because this overcounts. Well, in terms of the b's, how many are there? There's 2, so I have to divide by 2 factorial. And then in terms of g's, how many are there? There's 1. So I have to divide by 1 factorial. And that is how I get a value of 3. Now in terms of b's and g's, how did I get the top number? Well, it was basically b plus g, which in our case was 5, subtract 2. Why? Because I'm putting 2 of them on either end. So the top is b plus g minus 2 factorial. Like that. And then the bottom, remember, the g's, I got to take away 2 of them. So it's g minus 2. That is how many I have left to go in the middle. And then from the b's, I'm not taking away any of them. So it's just a full b factorial. And in our case, there was 2. So that is the formula for this scenario. And there we go. Now, how do I figure out the probability? The probability has to equal half. But in this scenario, what is my probability? Well, how many of these did I get? I got just 1, right? So it's 1. Plus how many of these did I get? I got 3. And what was the total? The total was 10. So the probability of getting a scenario where when you arrange them you have the same color on either end is 4 over 10, which in lowest terms of course is 2 over 5. Now we have to do that in terms of these formulas. And when we do, it has to equal a half. So that's the setup of the question. So let's write that in. We've got b plus g minus 2 factorial all over g factorial times b minus 2 factorial. And we have to add this to it, just like how I did numerically. And that's going to be b plus g minus 2 factorial all over g minus 2 factorial times b factorial. And I have to divide all of this by this guy right here. b plus g factorial all over b factorial times g factorial. And that is the equation I have to solve. And this might seem a bit daunting, but the good news is that very quickly a lot of things cancel out. And remember, this has to equal a half. The first step is I have to add this fraction here at the top. And I can do that by breaking up the denominators slightly. So what I did here is basically I took this g factorial and broke it up into g times g minus 1 times g minus 2 factorial. And then in a very similar way, I took this b factorial and broke it up into b minus 1 times b minus 2 factorial. And what that does is allows me to add the fraction. So multiply top and bottom by b times b minus 1 to get a common denominator right here. And multiply top and bottom over here by g and g minus 1 to get a common denominator. And that will allow me to add the fraction. So this now becomes b times b minus 1 times b plus g minus 2 factorial plus g times g minus 1 times b plus g minus 2 factorial. And then the denominator becomes the following: b times b minus 1 times b minus 2 factorial times g minus 1 times g minus 2 factorial, like that. And then don't forget, this is all over b plus g factorial all over b factorial times g factorial, like that. Now things start to simplify really well. This line right here, I can factor out the b plus g minus 2 factorial since it appears with both terms. And that leaves me with just b times b minus 1 plus g times g minus 1, like that. And then this line right here simplifies very nicely because these three terms combine to give just b factorial. And very similarly, these three terms combine to give me just g factorial. And then of course that is all over b plus g factorial over b factorial g factorial, like that. And let's not forget that this is all equal to a half. It must be equal to a half according to the question. All right, if you invert and multiply, you will get the following. And the good news is this cancels with that. So I hope you noticed that. So now I am just down to one fraction instead of two fractions. And that is the following. Now at this point, the numerator here, or the component of the numerator, and the denominator look very similar. Basically it's b plus g minus 2 factorial, and on the bottom I can break this guy up into b plus g minus 1, and then b plus g minus 2 factorial. And if I do that, I can cancel this. And of course, don't forget that term right there. And that, of course, equals a half. So we are almost done with this. That cancels with that, and that just leaves us with the following. So as you can see, I know it was a bit daunting in the beginning, but if you don't make any algebraic mistakes and just kind of go through this, and you have a little bit of knowledge of factorial notation, this isn't really that bad. And at this point, this is just basic algebra. So now we are down to this, cross multiply. And of course, I've got to expand this now. And then I will collect all the like terms and place everything on one side. Now at this point, I'm done with my simplifying and collecting like terms. These three terms, if you combine them, they will basically be b minus g squared. And that just leaves me with b plus g that I will place on the other side. And this is now our equation that we have to deal with. And keep in mind that our parameters were 4 is less than or equal to b, is less than or equal to g, is less than or equal to 2007. So we have to find all the solutions for these parameters that solve this equation. So how do we do that? Well, notice one thing, that b plus g is equal to something that is a square. So that means that b plus g is a perfect square. So to figure out what are our possible perfect squares, what I'm going to do is look at this set of parameters. First, let's look at our minimum and then our maximum. The smallest possible values of b and g is when they are both equal to 4, right? And that would mean that the sum is 8. The largest possible values of b and g are when they are both equal to 2007, and that would give you a value of 4014. Okay, so I've got to basically look at all the perfect squares in between those two numbers. All right, so this number is right below 9. So it looks like 9 is possibly my first perfect square, and that's 3 squared, of course. This number is a little greater than 63 squared, which is 3939. If I go up to 64 squared, it becomes greater than 4014. So this is the range. It's got to be somewhere in that range. So 4 squared, which is 16, 5 squared, which is 25, of course, and similarly 62 squared, which is 3844, 61 squared, which is 3721, ... So at first glance, you say, okay, well, we're done. All the perfect squares from 3 to 63, and that looks like there's 61 of those. And is 61 an answer choice? It is. It is choice D. But please don't circle choice D and move on or end the contest, because we have to verify if it will actually work with our parameters. So let's look at the first 3, and then I'll look at the last 3. I think that should be sufficient. So let's start with the first one right here. B plus G is equal to 9. And if that is the case, B minus G all squared is equal to 9. Correct? Going right by that formula right there. So that means that B minus G, if you take the square root, is equal to 3. This equation plus this equation, if I add them, gives me 2B is equal to 12, and therefore B is equal to 6. And if I substitute that back into the first equation, I get G is equal to 3. Does this satisfy my parameters? And the answer is no, because G has to be greater than 4. So this is no good. Now let's look at the next scenario. And that is 16 right here. So in a very similar way, B plus G is now 16. B minus G all squared is 16. So if you take the square root, we get B minus G is equal to 4, and then add the first equation to this equation, And we get 2b is equal to 20, and therefore b is equal to 10. Substitute that back into the first equation, and you get g equal to 6. Does that work? Yes, it does. So we got 1. Now, obviously, we're not going to go through all 63 of them, but we just want to see if this pattern kind of continues in our favor. And I'm sure that it will. And so I won't go past this guy. And then very similarly, I want to try from the other end to see if I need to disqualify any of those. So here we go. The next one is 25, so b plus g is 25. B minus g squared is therefore 25, and therefore b minus g is equal to 5. Adding the first equation and the third one, I get 2b is equal to 30, and therefore b is equal to 15. Substituting back into the first equation, I get g equal to 10. So it looks like we'll be fine from this point on. If I do the next one, which is 6 squared, 7 squared, 8 squared, they will all satisfy this parameter. But now I have to do the same for the other end, because the ends will most likely give us perhaps a couple that will be disqualified because they will not fit our parameters. So here we go. Let's try this one right here. So in a very similar way, b plus g is equal to 3939. B minus g squared is equal to 3939. B minus g is therefore equal to 63. First and third equation, if you add them, you get 2b is equal to 4032, and therefore b is equal to 2016. Well, it's not in that range, so therefore we have disqualified one more. So you see the importance of having to calculate at least some of them instead of just circling 61 for the answer. So let's do a couple more, and I think that should be enough. B plus g is now equal to this guy, 3844. B minus g all squared is equal to 3844. And then b minus g, if you take the square root, is equal to 62. Adding the two equations, you get 2b is equal to 3844 plus 62, which is 3906. And therefore b is equal to 1953. And g will be equal to 1891. Are they within our parameters? And the answer is yes. And I think we should be okay with just one more for verification purposes. And here we go. B plus g, this time 3721. B minus g all squared is 3721. B minus g is therefore equal to 61. Adding the first and third, 2b is equal to 3782. And therefore b is equal to 1891, and g will be 1830. Is that within our parameters? And the answer is yes. So there we go. So the verification system that we employed tells us that of these 61, 2 are invalid. So I have to subtract those. And that means the number that are valid in terms of our parameters is 59. So the answer to this very cool question is 59, and that is choice E.